All right, geometry video 2 for our 9-2 notes on coordinate proofs. And again, buckle up because we're about to do a 3-slide coordinate proof here on the concurrency of the medians theorem. So if you recall what a median is, a median in a triangle connects a vertex to the midpoint of the opposite side. Right, where they intersect is called the centroid. Right, so we are trying to prove the concurrency of the medians, which means that this point, the centroid, is on all 3 medians, or that the medians are concurrent, meaning they all intersect at the same point. So here's the picture we're going to use, and again, I'm glad they used 2's with their generic coordinates because again, we're going to use the midpoint formula. Right, so in this proof, we are given. And again, I wish they would give you this part. So we're given triangle ABC with medians AD, BE, and CF. And we want to prove that they are concurrent. Prove that the medians are concurrent. So again, here's what we're going to do, right? We're going to start with AD and CF. The reason I'm using AD and CF is because they have zeros as part of their coordinates, which I think makes them easier to work with, right? We are going to use a system of equations to find where they intersect, call it P. And then we're going to try to prove that P is also on median BE. That's our steps, okay? So it's a 4-step process, all right? So step number 1, right, is I want to find the equation of line AD. Okay, so first off, I need to find the coordinates of D. Again, D is the midpoint of BC, so to find the coordinates of D, I'm going to add the x's of B and C, so 2a plus 2c divided by 2. I'll add the y's, 2b plus 0 divided by 2. All of these 2's will cancel in this first fraction to get you a plus c, and then 2b plus 0 is 2b, 2b divided by 2 is just b. So there are the coordinates of D. Okay. So now, to find the equation of the line, I need the slope. So let's find the slope of AD. So to find the slope of AD, I'll take the y's and subtract the y's on top and the x's on bottom. Now I'll do D's coordinates first. So it's the y of D, which is b, minus the y of A, which is 0, and the x of D, which is a plus c, minus the x of A, which is 0. And that's just going to be b over a plus c. And there's your slope. So then to find the equation of the line AD, I will use point-slope form. The point I will use is 0, 0 because that's easy. So it's just y minus 0 equals the slope b over a plus z times x minus 0. And of course, those zeros don't matter, and your equation is y equals b over a plus c x. Okay, so there's the first thing we're going to do. All right, so I'm going to write that up here. So this is for line AD. Y equals b over a plus c x. Okay, and I'm going to erase this, and we're going to look at CF now. All right, so let me erase it real fast. Okay, so let's do part 2 in green. So this is to find CF. All right, so to find line CF, the first thing I'm going to do is find point F. Again, F is the midpoint of A and B, so take the x's and add them. So 2a plus 0 divided by 2, 2b plus 0 divided by 2. That's just going to be A, comma B. There we go, and there's the midpoint F. Now we're going to find the slope. This is the slope between F and C. So again, you can do it either order. I'm going to take the coordinates of F's points and subtract the coordinates of C's points. So it is the y of FB minus the y of C0. Again, the reason I picked F's coordinates first is because I did not want this to be negative B up top. I want this to be positive up top. And then for the x's, take the x of F, which is A, minus the x of C, which is 2C. And this is just B over A minus 2C. And now we're going to find the equation of line CF, and to do that we'll use point slope form. It doesn't matter which coordinates you use. You can use F's coordinates, which are A and B, or you can use C's coordinates. I'm going to use C's coordinates again because I have a 0. So this is y minus 0 equals B over x minus 2c times x minus 2c. So the y minus 0 cancels, so y is by itself, and over here I'm going to distribute this. Okay, so I'm going to get, you could do it two ways. I made it one big long fraction. Okay, so I did this just goes up top and I distributed, so I did bx minus 2bc all over a minus 2c. You could, if you want to, have two separate fractions, but again, let's just keep it like this, right? But this is an equation of a line. All right, so now I'm going to put that, so this is what I wanted, so I'm going to put that up here. So this is for CF, so y equals bx minus 2bc over a minus 2c. Okay, cool. So now I'm going to do step 3 right here. Again, I gave you, I think, multiple slides, right? I think, hopefully I gave you 3, right? So hopefully you could do both of those on this slide. And then the next slide, we're going to solve the system to find the intersection of point P. Let me erase. Okay, so step 3 here, I'll go to purple, right? We want to find point P. Find P. And of course, P is going to be where A, D, and CF intersect. So find point P, intersection of lines AD and CF. So that'd be this point right there, call it point P. So because these two equations both say y equals and y equals, we can go ahead and set the right sides equal to each other. Now I am going to put this x up here with the b, okay? So we're going to say that bx over a plus c equals bx minus 2bc over a minus 2c. And this is definitely a world-class algebra problem. Now, these are fractions. This is a proportion, so we're going to cross multiply. I'm going to put the a plus c in parentheses, the bx minus 2bc in parentheses, the a minus 2c in parentheses, and I'm going to cross multiply. So I did the bx times the a minus 2c on this side. And on the right-hand side, I did the a plus c times bx minus 2bc on this side. Again, it's all very messy, right? Okay, let's distribute. So I go in alphabetical order, right? So bx times a is a bx. Bx times negative 2c is negative 2bcx. Again, very easy to make mistakes. Try not to. Over here, a times bx is abx. I notice that's going to cancel. Great. A times negative 2bc is negative 2abc. C times bx is positive bcx. And c times negative 2bc is negative 2bc squared. Okay, so first and foremost, the abx's cancel. And then I do have some like terms here and here, and I do want to combine my x terms. So let's subtract bcx on both sides. So I'm going to do that right here. So what I get is negative 3bcx equals negative 2abc minus 2bc squared. Okay. And now I'm going to get x by itself, because that's what I'm trying to find. I'm trying to find the coordinates of x and y, right? X comma y. I want to find the x coordinate. So divide this by negative 3bc. And I'm going to divide each thing over here by negative 3bc. Because things will cancel, right? So over here, you just get x. And on this side, negative divided by negative is a positive. So you get 2. And then on top, the a stays. But then the b and c cancel, and that's over 3. Again, negative, negative cancel, plus. Again, the 2 over 3 stay. This c becomes a c to the first power, cancels out with that c. The b's cancel, so you get positive 2c over 3. So you can have it like this. The book actually kind of puts it together, which is helpful for the next step. So I'm going to put it together like this. They pull out the 2 on the top. They put the a plus c together, and then make a 3 on the bottom. Again, I think it's just helpful when you plug it back in for y in the next step. So here's what x is. Again, crazy, right? 2 2/3 of a plus c, really. But 2 parenthesis a plus c over 3. So now we need to plug that into one of these equations for x. I'm going to choose to do it in the first equation because, again, this first equation is a lot simpler. So this is going to go in place of x right there. And it goes on top with the b. So I'm going to do this in orange. I'm going to try to sneak it in right here. So we're going to do y equals b times 2 times a plus c over 3 all over a plus c. So what's going to happen is this b is going to go on top with the 2. And then this is really divided by a plus c, which is really multiplying by 1 over a plus c. So this a plus c is going to go down here with the 3. So it's going to be y equals 2b over a plus c all over 3 times a plus c. And this is why I said it was nice how they did this, because they had the foreknowledge that the a plus c's were going to cancel, and your y value would just be 2b over 3. And there's your y value. So now we have what the coordinates of P are. P is this ordered pair, right? 2 times a plus c over 3, comma 2b over 3. And now we need to do the last step, which is find the equation for line BE, and then we're going to see if P also lies on that line. Okay? So again, you have more paper. I'm going to erase this work, and we'll do it all right here on my screen. Okay, so this is step 4. I'm going to do it back in red. So step 4, we're going to check to see that P, or show that P is on line BE. Sorry for that. It's going slow for some reason. Hopefully it's not slow in the video. Okay, all right, so I have this point. I need to now find BE. So we need to find point E. E is the midpoint of A and C, so add the x's, divide by 2, add the y's, 0 plus 0, divide by 2. So 2c divided by 2 is just c, and then the y is 0. So that's a nice point. So now we need to find the slope of BE. So I'm going to take B's coordinates and subtract E's coordinates. So the y's would be 2b minus 0, and the x's would be 2a minus c. And that's just going to be 2b over 2a minus c. Okay, and now we need to find the equation for BE. So to find the equation of BE, I will use E. E's coordinates are pretty simple. So we're going to do y minus 0 equals 2b over 2a minus c times x minus c. And again, just like we did for the CF, we're going to bring this to the top and distribute the 2b. The 0 goes away, so y equals, so we have 2bx minus 2bc all over 2a minus c. And now what we want to do is we want to plug in, I want to plug in x of point P. I'm going to plug this in for x and verify that you get this out for y. Okay? So I'm going to write this equation down right here. So y equals 2bx minus 2bc all over 2a minus c. I'm going to erase this work, and again, we're going to show this substitution and the simplifying. Okay, so again, we're still in step 4. So I'm going to take this equation. So y equals 2b, but in place of x, I'm going to take this thing. So this is going to be 2a plus c over 3. So that's my x term. Minus 2bc, sorry about that, minus 2bc all over 2a minus c. And again, I know what I want to get. I want to get 2b over 3, so let's make that happen. Okay? All right, so we are going to simplify everything up here. Okay? So this 2b goes up here. So this is really like distributing a 4. We're distributing a 4b into that parenthesis. Okay? So this is going to be y equals, so this is a 4ab plus a 4bc, that's a 4, not a y, of 4, all over 3 minus 2bc all over 2a minus c. And now we're going to break this fraction apart. So this 2a minus c is going to go in this fraction with the 3, and over here it's going to go in the bottom of that fraction. Okay? So I'm going to go left to right now. So we're going to do 4ab plus 4bc all over, and we're not going to distribute. 3 times 2a minus c. So that's the first fraction. Minus 2bc all over 2a minus c. And in order to combine these like terms, we need, to combine these fractions, we need the same denominator. I see a 2a minus c and a 2a minus c. This second fraction is just missing a 3. So put that in parentheses, multiply the top and bottom by 3. So now what you're going to get is the following, and I'll put it right here. So this will all combine into one big fraction. So the top will be 4ab plus 4bc, and then this is minus 6bc all over, and this is 3 times 2a minus c. So these will combine to get you a negative 2bc. So we'll have 4ab minus 2bc all over 3 times 2a minus c. And from the top here, we can take out a 2 and a b. So we have 2b. We're left with a 2a minus c all over 3 times 2a minus c. And because we have 2a minus c on top and bottom, they cancel, and we get our nice 2b over 3. And we're done. By doing that, we proved that P is on all the medians, which means they are concurrent at that point P. Wow. Can you believe you just did that? I almost can't. I'm hoping that this video really did record. All right, so that's just video 2. We got one more similar problem to do with this last third video. All right. Hope you're still with me.